Good morning all of you. Now today we are going to solve this numericals of the chapter effect of electric current. So that first example, now heat energy is being produced in a resistance in a circuit at the rate of 100 watt. That power is given, okay, P is given is equal to 100 watt and the current of 3 ampere is flowing in the circuit. So I is equal to 3 ampere. So what must be the value of the resistance? We have to find the R. Okay. Now by using this formula, P is equal to I square R. Okay. Now how this formula came? Now in the this textbook, now we are having this formula that power is equal to voltage into current. Okay, P is equal to V into I. Now how this formula came, we have to just, I will show you. Now we know that as per Ohm's law, V is equal to IR. Now if we put this value of V in this equation, so it will become instead of V I am writing IR, I into R. Okay, P is equal to I into R and again I as it is. Okay, so if you multiply this I into I, that is I square, and R is here. Okay, so P is equal to, or power is equal to I square into R. Okay, so this is the formula we have taken. Okay, so we can take this three types of formula for the power. First is the P is equal to V into I. Then second one, P is equal to I square R into R, and the third V square upon R. So this is also, this formula also is some arrangement. Okay, according to some arrangement it came. Okay, so now we will use this formula, P is equal to I square into R. Okay, now power is given here 100 watt, that is 100 is equal to I is 3. Okay, so that we have taken whole square into R as it is. Okay, R we have to find. Now 100 as it is into, now 3 into 3, that is 9 into R. Can I write this as now 100 is equal to 9 into R. So we can write R is equal to 100 upon the 9 will come down, and if you divide this 100 by 9, so we are getting this 9 ones are 9, then again 1 is remaining, 10 is there, again 9 ones are 9, so 11.11 ohm. Okay, so in the textbooks there it is given here 11 ohm. Okay, so this is the first numerical. Now come to the next numerical. What is that? In this next numerical we are having two tungsten bulbs, okay, of wattage 100 watt and 60 watt. Okay, so power are given of the two bulbs. P is equal to 100, we will take P1 is equal to 100 watt and P2 is equal to 60 watt. Okay, power and the voltage is given 220 volt, that is potential difference, V is equal to 220. Now if they are connected in parallel, how much current will flow in the main conductor? Okay, so we will see, we have to find I. Okay, I we have to find. So now in this case P1 is, we have taken 100 watt, P2 we have taken 60 watt. Now voltage is given here 220. Okay, now we know the formula, power is equal to V into I. Okay, now if you just make the arrangement, I is equal to, we can write P, V will come here down, so that will I is equal to P upon V. Now as we have to find the current, okay, that the current are flowing from the two bulbs, that is P, that is 100 watt bulb and 60 watt bulb. So we have taken here I1 is equal to, now P1 first bulb, P1 upon voltage. Okay, this formula we are using, this is the general formula, I is equal to P upon V. We got this formula from this. Okay, now I have written here, instead of I have written I1 is equal to, instead of P I have written P1 upon V. V is common for both, voltage is single. So and also in the second formula is in the case of, instead of I have written I2 is equal to P2 upon V. Okay, now put the values here. We have to put the values, so it will become now current in the conductor is equal to I is equal to I1 plus I2. Okay, this conductor means that current is flowing from both the bulbs. Okay, so in first bulb I1 is the current, in the second bulb I2 is the current. Now I will write, instead of I1, in the previous case we have seen P1, I is equal to P1 upon V plus I2 is P2 upon V. Now can I write this as P1 plus P2, and this is common, we have taken voltage. Okay, so V as it is. Now is equal to, now what is P? We know that P1 is equal to 100 and plus 60, P2 is 60 upon voltage is 220. So if you add this 100 plus 60, that is 160 upon 220 as it is. Now if you divide this, okay, if you divide this, we are getting 0.727 ampere. Okay, now we that can be written now 0.727 ampere. As we know that the second figure, that is less value than this third value, so this will become 0.73. okay, so this is the answer. Now come to the third numerical, that is, now who will spend more electrical energy, that it is given here that first is the TV set having the 500 watt in 30 minutes, time is also there. Okay, then in this, or second is the heater that is having 600 watt in 20 minutes. Okay, so we will see now who will consume that more electric energy. So now we know that power of this first is the TV set and the second is the heater. Okay, so we will consider power for the TV set as P1 and we will write 500 watt, it is given, and for TV T1 we have taken time, that is 30 minutes. Now we have to convert this in second, so 30 minutes, that we know that 1 minute is equal to 60 seconds, so we will multiply that by 60 and you will get 1800 seconds. Okay, so this is the first timing, 1800 seconds for television. Then for the second, heater is there. Okay, so for heater we have taken P2 power, that is 600 given already, 600 watt, and timing for the heater, that is T2, it is given 20 minutes. So also again we will multiply 20, we will convert this in second, so that will be 20 into 60, that is 1200 seconds. Now we got the timing. Now we know the formula electric energy used, that is P into T. Okay, so that P into T. Now for television or TV set, we P1 we have taking P1 into T1, that is 500 into, that is 1800 second we are taking, we have converted now this 1800 second we have taken. So if you multiply this, we are getting 9.9 into 10 raised to 5 joule. Okay, just you multiply this and convert that in this 10 raised to 5, that will be 9 into 10 raised to 5 joule. Now regarding heater, now we have taken P2 600, P2 into T2, this is the formula. Now put the value of P2 is 600 into T2. What is T2? T2 is nothing but the 1200 second, that we are getting 7.2 into 10 raised to 5 joule. Now if you just compare, no, this value is bigger. Okay, so we will consume that thus TV set will spend more electric energy because it has a value more about the, it has consumed the more electric energy than heater. So this is the answer. Now the last one, last numerical, that is an electric iron of 1100 watt is operated or is used for 2 hours daily. Okay, so an electric iron is there here, that is having the power of 1100 watt, is used for 2 hours daily. What will be the electrical consumption expense for that in the month of April? So they are asking that how much electric consumption will be there. Means first we have to find how much electric energy has been consumed, and per unit how much, what is the charge is given, rupees per unit, 5 rupees per unit. As you know that in the month of April 30 days are there. Okay, so we will now calculate first how much electric energy is consumed. So first one is that power is given, P is equal to 100 1100 watt. Then time is given 2 hours and 30 days are there in the April month, so that will be multiply, that will give us 60 hours. Okay, now, and the unit per unit rate is given rupees 5. So we have to find the expenses of this month. Okay, so that will give us power. We know that it energy, that is P into T, that is power into time upon 1000, that we have to convert, that is in hour. Okay, WH we have to convert that, so that will be 1100 into 60 upon 1000. That will, if you just multiply this one, it will get 66 unit. So this is the electric energy consumed in the month of April. Now we have given 1 unit as rupees 5, the rate is given. Okay, so just if we have to multiply this, so electric consumption expenses will be 66 unit into rupees 5, and that is coming rupees 330. So this is the expenses of the month of April. Okay, so thank you very much.